Yo, how's it, man? Alright, let's jump straight in. So, over here, don't be tempted to distribute this in because this thing is factorized and it equals 0. If that's the case, you grab each factor and make them equal 0. So that's exactly what I've done here. Here's factor 1, I make that guy equal 0. And then make sure to separate your solutions with the word OR. Here's factor 2, and I'll just grab him and make him equal to 0. And now I've got to work on getting x on its own with both of them. In this equation, I'm going to divide both sides by 2, which will just leave me with a first solution of x equals 0. On this side, I'm firstly going to take the 4 over, and it becomes negative 4. And then I need to get rid of this 3, so I divide both sides by 3 over here. And I get my second solution to be minus 4 over 3. If you pop that into the calculator, it does not simplify, it just stays like that. So let's have a look where our 2 marks are coming from. You're purely just going to get the marks for your solutions. So if you're comfortable enough, you can jump straight to the solutions. Next question, we've also been asked to solve for x here. And we have a massive clue. I can smell the quadratic formula when they give me this clue. So I've just grabbed the quadratic formula here. This little tick means it is on the formula sheet. And then the a, b, and c values are extracted from standard form. So we've got to go get standard form with this thing. To do that, we're just going to move this minus 1 over and it becomes plus 1, and then we can get our a, b, and c values. Okay, after we've done that, here's a, this minus 4 is b, and this 1 is c. I'm going to chuck them into this formula. Okay, so I've made the necessary replacements. Just remember to use brackets if your number is a negative. It always helps with the substitution. Even if they're positive, I use brackets. I just see the multiplication better. Okay, now do not waste time doing mental maths here. This is going straight in the calculator. So when you type it in the calculator, just do the plus 1 first, press equals, and then they want 2 decimal places, so we're going to switch from basically our standard form to decimal format, and then we're going to round off to 2 decimal places. The 7 rounds the 0 up to a 1, so our first solution is 1,71. Okay, now don't retype the next one, just press right on your calculator and then go to the positive over here, rewrite it with a negative, and then press equals, and here lies our second solution. This 2 will round that 9 down, so it just stays 0.29, and there's our second solution. And lastly, let's have a look at where the marks are coming from. I get 1 for standard form. I get 1 mark for substitution into the quadratic formula, and a mark for each answer, which makes up our 4 marks. This question presents us with a quadratic inequality. This symbol is an inequality symbol, and there's an x squared hiding in here. We're only going to see him after we FOIL. So to set myself up for foiling, I'm going to write the bracket twice. The square is kind of telling me to write the bracket twice. And now I want to go for that standard form so I can factorize, get my critical values, and do that whole process. So I'm going to FOIL these brackets, and at the same time I'm going to bring this one over to that side. Once that's out the way, I've just got to sort out a couple of like terms here before my trinomial reveals itself. So plus 4 minus 1 is just plus 3, so let's simplify that a bit. And now I've got a trinomial that I need to factorize, so I look at the factors of 3. 3 is a beautiful little thing because it's only got 2 factors. It's a prime number, so it's 1 times 3. And now I need to use those factors, add or subtract them to get this minus 4 in the middle. So if I say minus 1 minus 3, that will give me the minus 4 in the middle. And from there I can create my 2 brackets. My first bracket will be x minus 1, and my second bracket will be x minus 3. And now I'm going to get my critical values. Your critical values just come from like if you had to solve for x. So it's like you make x minus 1 equals 0 and you take the 1 over. I'll actually illustrate that on the side so you can see how I get them. So we grab that first factor, make it equal to 0, take the 1 over, and we just get x equals positive 1. That's how I get this first critical value. And in a similar fashion, if I had to take the minus 3 over, I would get x equals positive 3 for my second critical value. That's what CV stand for, by the way, critical values. And I'm just going to get rid of this because we're going to draw our parabola now. When we draw our parabola, we can see this is a happy face because the number in front of x squared is positive. It's a sneaky little 1. And then we put the lower critical value on the left and the higher critical value on the right as the x-intercepts of the parabola. Now it's kind of asking you, where is the y value of the parabola greater than 0? So if we have a look at the y-axis, it's where the parabola is above the x-axis, because then it gives you a positive y value. So it's the outskirts of the parabola. So we've got to write these two little regions as inequalities, or we can do interval notation. I'll do both for you. So this first region is whenever x is smaller than 1. And also just make sure that if you have an equals to sign here with this inequality must have an equals to sign. The next region is whenever x is greater than 3. I'm going to get that positive y value. And that forms my final answer over there. So I can also write it in interval notation. I'll show you that quickly. So interval notation will be from negative infinity all the way to 1 and from 3 all the way to positive infinity. That means the exact same thing as this does. It's up to you, your personal preference of which one makes more sense to you. Let's have a look where the 4 marks are coming from. So your 4 marks will come from standard form, factorizing the correct critical values as well as the correct answer. Alright, we've got a classic surd equation. A surd is a root, so when I see this root I know it's a surd equation. So without solving for x, we need to show that the solution lies in between 2 and 4. So we're going to use the principle with the square root that you can't square root a negative. Because when you square root negative numbers, you get non-real stuff and your calculator freaks out and gives you a math error. So what's underneath the square root has to be positive, and how I say that mathematically is like this. What's under the square root must be greater than or equal to 0. That's another way of saying it's positive. And then I just move this 2 over and I get x is bigger than 2. And then that's basically half of our solution. You can see the crocodile is eating x here. The crocodile is also eating x here. So to get the other half, this needs to be bigger than 0. And the reason why is when you square root something, you're going to get something that's positive. Now I know what you might be thinking. If I square root 9, it's going to give me positive 3 and negative 3. But they've gotten rid of the negative. You see how there's no plus minus in front of the root here. So that's why we can just assume that this side is going to be bigger than or equal to 0. And then I take this x over and it becomes positive. And now we've got the other half of our solution. You can see how the crocodile eats 4 there. The crocodile also eats 4 there. So I can kind of like mash these together into this inequality. X needs to be bigger than 2, but at the same time, x needs to be smaller than 4. And presto mundo, we are done with this question. Let's have a look where the 2 marks come from. So your 2 marks purely come from these 2 lines, modeling the right stuff to be bigger than 0. Next up, we've been asked to solve the equation. So I'm going to grab the equation quickly. And then I want to make sure the root is on its own. There's no like plus 3 or minus 3 in front of it. So it is on its own. So that means I'm going to square both sides. When I square the side, the square gets rid of the root. That's actually why we square both sides, to get rid of this root. Then over here, I'm going to write the bracket twice. The square is giving me instructions to write the bracket twice to set myself up for foiling. Okay, so let's go ahead and foil these two brackets. And after we foil, we have a little quadratic equation on our hands. I knew that because I saw x squared over here. So I want to get my standard form, factorize, and all that jazz. So to get standard form, I need the right order. So I'm going to put the x squared first over here. I want the ones with x's in the middle. So I'm going to keep this in the middle. And I'm going to bring that x over to the middle here. Just keep in mind, when I take this over, it turns into negative x. And then the 16 will go at the end, and I'm also going to bring this minus 2 over to the end. And now that I've taken everything over from this side, this is a 0. There's nothing left over there. It's kinda my bro. So now let's quickly sort out these like terms here and here, as well as here and here, and then our standard form is done and we can start factorizing. Right, so our standard form, I need to look at the factors of 18. That'll give me negative 9. 1 and 18 will not work. 2 and 9 will not work. 6 and 3, I think that will work. And then to get that negative 9 in the middle, I'm going to have to say minus 3 minus 6. And then I can formulate my two brackets. My first bracket will be x minus 3, and my second bracket will be x minus 6. And now I can jump to my two solutions of 3 and 6. Okay, now we're not quite done. This is a third equation, so you've got to be careful. One of these solutions is probably not valid. And they actually kind of try to give us a clue about that in the previous question. So in the previous question, we established that the solution for this equation lies in between 2 and 4. And only one of these answers is in between 2 and 4. It's a 3. 6 is not in between 2 and 4. So we have to reject the 6 to get our full marks over here. And we just do that by putting a stroke through this equal sign. And lastly, let's have a look where our 4 marks are coming from. It will come from squaring both sides, standard form, the correct factors, and choosing the right answer of x equals 3. Question 1.4 is a bit of a weird one. So we've got prove that RS equals this thing, and we've been given these two equations. So if they say prove that, it means that you're only allowed to work with one side of the equation. So it's normally the more complicated side you go for. So I'm going to grab the right hand side of this equation. And I've got an equation for A, an equation and an equation for B. So I'm just going to sub them into A and B. Just remember to use brackets when you do sub them in. Alright, the square means I multiplied by itself. So I'm going to write the bracket twice to set myself up for foiling. Alright, let's get the painstaking task of foiling out the way. Once you have foiled, just remember to keep this oak in a bracket because we're going to have to distribute this minus, and that's exactly what we're going to do next. Once that's out the way, we're going to see some magic happen here. When we do the like terms, most of them are going to cancel. So r squared cancels with this r squared because they're opposite signs. And the same thing happens with the 4s squareds. They will cancel with one another. And then these two are like terms because they've got the same variables with the same powers. 4rs plus 4rs will give us 8rs. And then these 8s cancel with one another, leaving us with just rs, which is what is on the left hand side. So our job is done once we've completed that. And your 4 marks will come from the correct substitution, expanding that using FOIL, as well as simplifying that to get the final answer. Question 2 gives us a stock standard arithmetic sequence, and we need to get a simplified expression for Tn. So I need to get my difference to accomplish that. Looks like I'm subtracting 3 every time, so that is my constant first difference. And then we have a look on the formula sheet for our Tn formula for an arithmetic sequence. And then we're just going to plug everything into this formula. So Tn just stays behind. The first term of this pattern is 85, so that's going to go in A's place. We leave n here if we're getting Tn, so n is just going to stay. And my difference is this -3. I'm subtracting 3 every time. Okay, now we can't leave our answer like this. They want it simplified. So to simplify it, I'm going to distribute the -3 in that bracket. And last thing left to do is the like terms. 85 plus 3 will give me 88. Your 3 marks will be earned from the correct substitution, the correct d value of -3, as well as your simplified answer. The next question asks, which term will be the first negative number in the sequence? So we have to use the equation we got for it to accomplish this. So we grab this equation and we model it to be less than 0. And basically how you translate this in maths is, where is this thing smaller than 0? Another way of saying smaller than 0 is negative. So where is this thing? Negative. Right, and now we just solve for n, and that's going to lead us down the path to get our answer. So let's take that 88 over. Just bear in mind it changes sign when it goes over. Now I'm going to divide by this -3 to get n on its own. And then just remember, when you're dividing by a negative, this must point in the other direction. So it's telling me n must be bigger than 88 over 3. I want to see what this is actually like. I want to see the decimal value of it. I want to see how big it is, essentially. So just press S to D, and it's 29,33. So what we've established, for this thing to be smaller than 0, n needs to be bigger than this number. So we choose the first integer that's bigger than 29,33, which is 30. So the first negative number in the sequence will be term 30. And your 3 marks are earned from modeling this thing to be smaller than 0. N is greater than this number, and your final answer will earn you the 3rd mark. Question 2.2. Yes, this is a little bit overwhelming. Okay, we've got a quadratic sequence. At least they told us what type of sequence it is. And we've got a general term with the following properties. Term 11 has a value of 190, and Tn minus Tn minus 1 equals 4n minus 3, so long as n is equal to 2 or bigger. And they want us to determine the first term of the quadratic sequence. Okay, so this over here is a very complicated way of giving you the rule for your first difference. So any given quadratic sequence, I kind of set this placeholder up. So you want space for your quadratic pattern at the top. You want space for the arithmetic pattern that forms the first difference in the second row. And the last row should be comprised of the same numbers because it's constant. It's a constant second difference. Unfortunately, this is not on your formula sheet. So all of this you'll have to know off by heart. Okay, so in a very complicated way, they gave me the pattern rule for the arithmetic pattern. When they say Tn minus 1, it's basically like saying this one minus this one gives me that one. But they've given you the rule that applies to all of them. So we're going to use that rule to our advantage. We're going to use that rule to get these 3 numbers. Okay, so this is giving us instructions that you must start at 2 with this rule. So I'm going to replace these 3 n's with 2. Okay, and then I'm going to simplify that a little bit. 2 minus 1 is just 1. 4 times 2 is 8. 8 minus 3 will give me 5. And that 5 is going to be my first number over here. Okay, now I'm going to repeat that procedure with a 3 instead of a 2 to get the next one. You just go up by a whole number, so 2, 3, 4. We're going to get those guys now. Okay, 4 times 3 is 12. 12 minus 3 will give me 9. So my next number over there is a 9. And just for comfortability's sake, let's get this out quickly. And then 4 times 4 is 16. 16 minus 3 gives me 13. Okay, now that we've extracted those three, we can see we're adding 4 each time. So this number over here is 4. Okay, and now this will enable us to solve for A as well as B to put inside of our quadratic formula or quadratic equation for quadratic sequences. So over here, I just divide both sides by 2 and A will be 2. And then 3A plus B will give me 5. And I put this A into this guy. So I put the 2 into A there and I'll solve for B. 3 times 2 is 6. If I move that 6 over, it becomes minus 6. And 5 minus 6 will give me negative 1. And then I just fill that into the placeholders of A and B. This 1 doesn't even have to be here, so we can get rid of it. And now we're running into a bit of a problem. We don't have the C value, and we have no way of getting it from this. So we're going to use this to get it. Term 11 has a value of 190. So we're going to pop those in here. The 190 will go in here, and the 11 goes in n's place. And then once we pop those in, we just need to solve for C. So I'm literally going to type this into my calculator. I don't want to do mental math and take a chance. So 2 times 11 squared minus 11 will give me 231. So let's make that replacement. And then we take the 231 over and it becomes a negative. So let's calculate that quickly with our calculator. Gives me minus 41. Once that's out the way, I just chuck it back into my Tn formula that I originally had. You just replace C with what it actually is, minus 41. And now they want the first term of the quadratic sequence, so I just replace all the n's with a 1. And after I've done that, that goes straight in the calculator, don't take chances. And there's my first term, minus 40. And your 5 marks are achieved from your first differences. So you don't actually have to show all this working out. You can just get them straight by putting them into your calculator. Second mark comes from the correct A value. Third mark, correct B value. Fourth mark, the correct C value. And the last mark comes from the correct final answer. Question 3 drops a bit of a sigma notation on our lap. So let's analyze the sigma notation. Alright, so this sigma over here has an infinity up there, which means it can be a converging pattern depending on the values of x. And that's what they're actually asking here. For which values of x will this thing exist or will this thing converge? So I can't really get the number of terms, but I have the pattern rule. So I'm going to sub this bottom number in to get my first term, and then I increase it by 1 and I get my second term, and I'm going to increase it by 2 to get my third term. So let me show you how to do that. So I just grab this bottom number and I put it in this variable's place, k. So I swap k with 1 and there's term 1. Now anything to the power of 1 doesn't change, so I can essentially get rid of this 1. And then to get the second term, I just go up by 1 here with bottom number and sub that in like last time. So the second term will be bracket 4x minus 1 bracket to the power of 2. And then I sub k equals 3 in there, and I'm going to get term 3. And now I've got my first 3 terms. Now, for which values of x will this thing exist, aka the sum to infinity? So let's grab our sum to infinity formula and have a poke at it. So with my sum to infinity formula, to actually use this formula, this ratio here must be smaller than 1, but at the same time bigger than -1. So that's the logic of this question. That's what everything revolves around. So I'm going to want to get my ratio and model it to be smaller than 1, but bigger than -1 at the same time. So let's go get our ratio quickly. So our ratio is obtained by saying term 2 over term 1. So I'm going to replace term 2 with this thing, and I'm going to replace term 1 with this thing. And now I've got to simplify that. Okay, to simplify that I can use exponent laws. So this bracket at the bottom has an exponent of 1, and 2 minus 1 will just give me 1. So it's this bracket to the power of 1. Or you can take this approach towards it. If you're squaring something, it means you're multiplying it by itself. And then one of these brackets will cancel with one of those. And that leaves us with a ratio of 4x minus 1. We don't need these brackets anymore because it's not being multiplied by anything. Okay, now this ratio, I want it to be in between 1 and -1. So I just model it like that. I just replace this r with this over here. So you can see I've just replaced that r with what the ratio actually is. And then I solve for x. So I'm going to plus 1 everywhere. And then minus 1 plus 1 is just 0. Minus 1 plus 1 is 0 again. So I'm only left with 4x in the middle. And 1 plus 1 will give me 2. Now I almost have x on its own. I just need to get rid of this 4. So I divide all 3 sides here by 4. And then I'll just simplify a little bit. 0 divided by 4 is just 0. 4 divided by 4, they cancel, and you're just left with the x over there in the middle. 2 over 4, if you pop that in the calculator or simplify it, it gives you a half. So when x is in between a half and 0, we will get the sum to infinity, and this thing will exist. And then one more small thing about the sum to infinity. Your ratio can never be 0. So that will affect our answer. So the ratio we got here, 4x minus 1, cannot equal 0. So I'm going to model that separately. So the ratio cannot equal 0. And then I take this 1 over, it becomes plus 1. And I divide both sides by 4. And I get x cannot equal a quarter. And then these 4 very hard fought marks will firstly come from the ratio, the condition that the ratio is in between 1 and -1, your answer, as well as the exclusion of a quarter. Okay, 3.2, the figure below shows a pattern of 5 circles touching externally. Now we've got a big length over here, which is all our diameters added together. And we say that the radii of these circles form a geometric pattern, where the radius of the smallest circle is 3 units and the largest circle is 48 units. And with that information, we need to determine the common ratio of the geometric pattern formed by the radii of the circles. So what they've essentially told us here is that term 1 is 3 units. And term 5 is 48 units. And then what I'm going to do with these two things is use my Tn formula for a geometric pattern. So with my Tn formula, the first term is A, and here's the first term. So that is A. A is 3. So now I can chuck all this information into this formula and solve for the ratio. So I'm going to put 48 in Tn's place, because that's the value of the fifth term. I'm going to put 3 into A's place. R is going to stay there because that's what I'm looking for. And the term number, it's the 5th term. So I'll put 5 in N's place. And then I'm going to start working on getting the ratio on its own. So I'm going to divide both sides by 3 to get rid of this 3 here. And 5 minus 1 will give me 4. So 48 over 3 goes straight in the calculator and it gives me 16. And then these 3's cancel over here. And 5 minus 1 gives me 4. Now to get rid of this power of 4, I 4th root both sides of the equation. If I 4th root 16, it gives me 2. Chuck that straight in the calculator. And these 4's cancel. 4 divided by 4 is 1. And you don't even need to write the power of 1. So our ratio is 2. Now let's see what that's kind of telling us. So what that's telling us is we're timesing by 2 every time to get the ratio of the next circle. So not the ratio of the next circle, the radius of the next circle. So the radius of the first one is 3 units. And then the radius of the second one, you times that by 2 and get 6 for this one. Times by 2, you get a radius of 12 there. Times by 2 again, and you get a radius of 24 there, so on and so forth. And then lastly, let's have a look where these 3 marks are coming from. Substitution into this formula gets you your first mark. Simplification into r to the power of 4 equals 16 gets you your second mark. And the answer of 2 gets you your last mark. 3.2.2 asks us to determine the value of L. L is this length over here. So I mean, we can be fancy and use a sum formula, but I mean, like, these numbers are right here. I'd rather just add them together. So bear in mind, this is just the radius. This radius will also be 48. And the same will be true for all these other lengths over here. So if I want to get the distance L, I'm just going to add all these numbers together. Okay, and then don't take chances. Pop that straight in the calculator to give you 186 units. In the question, they didn't say centimeters or anything like that. They said units. So we have to match that with units. And your 3 marks, 2 of them will come from adding everything together, and 1 of them will come from the final answer. Right, the last question in question 3. The pattern is extended by 5 more circles to 10 circles. Calculate in terms of pi the total area of the 10 circles in the new pattern. So I want to look at the areas. I don't want to look at the radii anymore. So let's have a look what the area of the first, second and third one is. Now the equation for the area of a circle is area equals pi r squared. So for the first circle, the radius is 3, so I'm going to make that replacement. And 3 squared is just 9, so the area of the first one is 9 pi. And then for the second circle, the radius of that thing is 6, so I'm going to replace radius here with 6. 6 squared is 36, so this one will be 36 pi. And then for the third circle has a radius of 12. So it's going to be pi times 12 squared, which will be 144 pi. So if I analyze these, it looks like I'm timesing by 4 every time, which is telling me this is another geometric pattern. And if I'm timesing by 4 every time, that's my ratio value. So I can get my ratio by saying this one divided by this one. I suppose we can be fancy and do that. So if you do that, term 2 over term 1, 36 pi over 9 pi, the beef and onion pi's cancel, and 36 divided by 9 is 4, and that's where this 4 will essentially come from. So now I need to get the total area of 10 circles. If I want the total area, I'm going to have to add all the areas together. So I've got to use the sum formula for a geometric pattern. And here it is. So my first term is 9 pi. So I'm going to put that in A's place. the constant ratio is 4. So I'm going to put that in R's place here and here. And the number of terms, I want 10 circles. So I'll put 10 into N's place. And then you can see I've made the necessary replacements over here. A first term, term 1 is 9 pi. The ratio is 4. And we are getting 10 circles. So that's why N is 10. Okay, now this thing is going straight on the calculator. There ain't no way I'm doing that in my head. So we have run into a bit of a problem by using the calculator. They want the answer in terms of pi. So there's got to be a pi in our answer. That's what they're saying. But if I type this into my calculator, it does not give me a pi in the answer. So what I do to overcome that is I just type it in without pi. So I'm going to get rid of this pi over here. And once I do that, it gives me this nice whole number. I just grab this whole number and I glue pi onto it as my answer. And then I've officially finished with this question. Yes, the patterns in this paper were nasty. Right, let's see where these 4 marks are coming from. So the first mark comes from getting the areas of your circles. Second mark comes from the correct ratio. The third mark comes from the substitution in the correct formula. And the last mark comes from the correct answer of 3,145,725 chicken and mushroom pie, my bro. Question 4 gives us 2 linear functions which are axes of symmetry for this function. Now this function is a hyperbola. Now you might be wondering, how do I know that? And it's because I recognize my standard form of a hyperbola. This is very essential to know off by heart because it's not on the formula sheet. So we can see like this equation has the same format as that, and they've given us the a value to be -4. So the hyperbola is going to look like this. Very powerful tool if you know this standard form. So we somehow need to get the p value and the q value, which are sitting over here and here. Now the mechanics of what's going on behind the scenes is quite complicated. So I'm going to walk you through it step by step. So for any given hyperbola, you have 2 axes of symmetry that run through this point over here. And the one goes uphill like this, and the other one goes downhill like this. So they've actually given us the equation of these 2 things over there and there. And I know that the one with the positive gradient, the number in front of x, 1 over here, is this one that goes uphill if you read it from left to right. And the one with a negative gradient, you see the negative in front of x, is the one that runs downhill. So P and Q are representative of the asymptotes of the hyperbola. So P will be this one that goes up and down, and Q is the one that goes left and right. So to get those, I need to find this point over here. This is a very special point. And that point is where these 2 axes of symmetry intersect each other. And to get points of intersection, you make the 2 graphs equal and you solve for x. So I'm going to make this one equal to that one and then solve for x. Okay, now that I've made them equal, I'm going to take this x over, it becomes positive x. I'm going to take this 1 over and it becomes -1. And x plus x is just 2x. 3 minus 1 is just 2. I divide both sides by 2 to get x on its own. And I get x to be 1. So now I'm going to sub that back into the graph to get my y value. This one looks a bit easier to work with. So if I put this x into that x's place, 1 plus 1 will give me 2. And that helps me conclude that this point of intersection between the axes of symmetry is 1 and 2. So the line going up is x equals 1. And the asymptote going left and right is y equals 2. And that will form my p and q values. So q is representative of the horizontal asymptote. So q is 2, as we can see there. And then this one must always be the opposite sign. If this is x equals 1, then this must be x minus 1. So we can just jump to our conclusion of p equals 1 and q equals 2. And let's have a look where the 3 marks are coming from. Equating these two equations gets you the first mark. Your x value gets you the second mark. And your y value gets you the last of the 3 marks. Now we have to get the x-intercept of g. So I'm going to need the equation to do that. So if I go back up, I'm going to grab this equation, but I'm going to fill p and q into this equation. And then to get the x-intercept, you've got to remember a small rule. You make y equals 0 and solve for x. So this g of x here is a placeholder for y. So we can just go ahead and change that to 0. And then I want to get this fraction on its own so I can cross multiply. So I'm going to take that 2 over and it becomes negative 2. And now I want to bring this up. It's sort of a shortcut of cross multiplication. When you bring it up, just remember to keep it in brackets because we're going to distribute this negative 2 in next. Okay, after we've distributed, we're going to take that 2 over and it becomes minus 2, minus 4, minus 2 is minus 6. And then lastly, we just have to divide both sides by negative 2 to get rid of this negative 2. And negative 6 divided by negative 2 is positive 3. And then finally, we have our x-intercept to be 3 and 0. X value of 3, y value of 0. Okay, and the 2 marks come from making y 0 over there. And the correct x value at the end of the day. Okay, and then all this hard work has been buttering us up to sketch the graph. Okay, so we've got the graph here. Let's see what we know about the graph. Alright, so this number on top will tell us which shape it is. Because that number is negative, it's going to adopt this shape. So let's get rid of that. And we also have the asymptotes of the graph. This number at the bottom is your vertical asymptote. And this number on the outside is your horizontal asymptote. So I'm actually going to start by drawing the 2 asymptotes. When you draw your asymptotes, just remember this one is the opposite sign. So it's x equals positive 1 and not negative 1. Then this one's just the normal sign, y equals 2. And y equals is a horizontal line, x equals is a vertical line. Now we know it's going to adopt this shape, so it's going to lie in this quadrant and this quadrant. So let's plot our x-intercept that we got earlier. This 3 and 0, that will lie somewhere on the right of this line, so I'm going to plop it over there. Again, I don't know what the y-intercept is. I know it's going to be somewhere here, but I don't know what it is. So you've got to work it out quickly because we've clearly got to show it. So to get the y-intercept, you make x equals 0 and solve for y. So this x over here, I'm going to make it to 0, and I'll change this to a y just to make myself a bit more comfortable. And then this thing is going straight in the calculator, and a chance I'm doing mental maths. Okay, if you pop it in your calculator, press equals, it gives you 6. And then I just need to clearly label that on the graph. You can see it's going to sit above this y equals 2 because it's y equals 6. And now I'm going to draw my hyperbola in. And then we are officially done. We've sketched what they asked for, we labeled what they asked for. So let's have a look where the 4 marks are coming from. Firstly, your y-intercept gets you your first mark. The vertical asymptote gets you your second mark. The correct shape of the graph gets you your third mark. And the horizontal asymptote gets you the 4th mark. And then the last question from question 4 asks us, for which values of x is g of x bigger than 0, aka is g of x positive? So we have to do this by looking at the graph. So g of x is a placeholder for y. So they're asking you where are the y values bigger than 0. So I can see that's happening over here. The y value is definitely bigger than 0 because we've got a 0 y value over there, and if we go down we get negative y values. So it's definitely working over here the whole way through. But then over here, it's got negative y values, so it's not working over there. So it only starts having positive y values again after this point. So these are the regions where it's happening, and we've somehow got to state that in x values. So there's two ways which we can do this. I'm going to show you both ways. So we can start at negative infinity and end at 1. And then how you write that is you say x is an element that starts at negative infinity. You always use circular brackets for negative infinity because it never includes infinities. And then that comes to a screeching halt at 1, the x value. And then I use circular brackets here because it's non-inclusive because there's no equals to sign over there. Then you put the word or and you state your second region. Now the second region is over here and it starts at the x value of 3 and goes on forever to infinity. And then that will be good enough to get you the 2 marks. Now the other way of stating it is when x is smaller than 1 or when x is bigger than 3. And you write it with inequality symbols like so. So it's really up to you to choose which one makes more sense to you. I find this one kind of creates a deeper understanding because you like know where to start and stop and then start and stop. So my personal preference is this top one over here. And let's have a look where the 2 marks are coming from. So 1 mark comes from like the correct values like 1 and 3. And the second mark comes from the correct notation. So are your inequalities pointing in the right direction? And do they have like the right equal sign or not equal sign, if you know what I mean? And then over here, the 3 and the 1 get you the first mark, and the notation, like the circular brackets, will get you the second mark. Jumping off in question 5, we've been given 2 functions, f of x, which is a parabola, and that's the sad face over here, and g of x, which is an exponential function. Anything to the power of x forms like a ramp like this, an exponential function. So I'm going to color code these guys quickly. Yeah, it's much better. Right, so like look what a difference that makes. I also like to write the equations nearby so that I have them on hand and I don't have to keep going back up to this. Okay, now we need the length of AC first of all. We've got A and C over there. They are very special points. So A and C are x-intercepts. They where the blue graph cuts the x-axis. And to get x-intercepts, I make y equals 0 and solve for x. And then just remember f of x is a fancy placeholder for y. So I'm just going to change this y to 0 and then solve for x. Alright, don't fall in the trap. The square means you write the bracket twice and FOIL. And then just remember to keep this negative in front, and now we're going to go ahead and FOIL those brackets. And then after we FOILed, we're going to distribute this negative inside the bracket. And then we've got a couple of like terms here that we're going to sort out. Minus 4 plus 9 will just give you plus 5. And now I can't factorize this thing just yet. This negative is bothering me. So I'm going to divide everything by negative 1. So essentially everything's sign will change. This will change to a positive, this will change to a negative, and this will change to a negative. Okay, now that that negative is gone, we can start factorizing the trinomial. So I look at the factors of 5. Oh my goodness, it's a prime number. What a dream. So it only has 2 factors, 1 and 5. So I've somehow got to add or subtract those to get this negative 4 in the middle. And I can accomplish that by saying plus 1 minus 5. And those will form my 2 brackets, x plus 1 and x minus 5. And from there, my 2 answers for x are these numbers with the opposite sign. So x equals negative 1 and x equals positive 5. After we got those, we've got to decide who belongs to who. So because A will have a negative x value because it's on the left of the y-axis. That has to be the negative x. So a is -1, which will make c +5. Okay, so we're getting to know the blue graph a little bit better. And to get the length of a horizontal line, you can use the distance formula, but there is an easier way that will be very worth your time to get used to. So you just take the x value on the left minus the x value on the right. Sorry, that's my bad. The one on the right minus the one on the left. So right minus left. Try and get used to that. Okay, so the name of our particular horizontal line is AC. So I'm going to change the name here to AC. The x value on the right is 5. And the x value on the left is -1. And then a minus and a minus give you a plus. So 5 plus 1 will be 6. And then just make sure to slap the word units onto that. And lastly, let's have a look where our 4 marks are coming from. First mark comes from making y equal to 0 to get x-intercepts. Second mark comes from your standard form. Third mark comes from the correct x values. And the last mark comes from the correct answer of 6 units. Next up, we need to determine the value of b. B is sitting snug in the equation of the red graph. So to get the value of b, I need a point on the red graph. So to get that is going to be quite tricky. You must just be careful. A is not on the red graph. The red graph is slightly above A over there. So we're going to have to get this point here, D. And I use that by looking at the blue graph. Now, I don't know if you've noticed, but this is in a very special format. It's in the turning point format of the parabola. And if it's in that format, I can extract quite a lot of things. I can get the x value of the turning point there, and the y value of the turning point at the end over there. So I know that D is the turning point of the parabola, because they did tell that to us in the question. D is the turning point of f, the parabola. So I can literally write down this turning point. It's 2 and 9. And now that I've got a point on the red graph, I can just sub that into this thing and solve for b. So I'm going to grab this equation. Remember, g of x is a fancy placeholder for y. And then your first coordinate, well, the first number in the coordinates is the x value. The second number is the y value. So this 9 will go into y's place, and this 2 will go into x's place. After we made that substitution, we need to get rid of the square by square rooting both sides. And the square root of 9 is just 3, so b equals 3. And then your 2 marks over here just come from subbing in the right point, as well as your answer for b. And then once I get this answer for b, I'm going to fill it in over there so that I know more about the red graph. Okay, and then the next question says, determine the values of x for which g of x, the red graph, is greater than 9. Right, remember, g of x is a fancy placeholder for y. So it's asking you, where is the y value of g of x bigger than 9? And so what I do with these questions is I draw a horizontal line through the y value of 9. And now it wants to know where this function is above that line. So it starts here, and then it goes on forever that way. So this is where you start, and you go to infinity. So there's 2 ways I can represent this answer. The first way is I can say whenever x is bigger than 2, this inequality occurs. And it will also equal 2, because we've got the inclusive symbol over there, the inclusive inequality symbol. Or what I can do is I can write it in interval notation. So I can say x is an element that starts at 2 and ends at infinity. And then I will have to use a square bracket over the 2 because I've got the inclusive symbol there. The square bracket means it does include 2. And then infinities always get round brackets. So it's really up to you. You must write this or this. Do not write both. Just use the one that makes more sense to you. And the 1 mark just solely comes from the right answer. So it's all or nothing with this question. 5.1.4 asks us to write down the equation of h of x, a new function, if h of x is the equivalent of f of x plus 2 minus 9. Right, so I'm going to start by writing this down. Now we have f of x's formula over here. Now what this is telling us to do is it's telling you replace your x's with x plus 2. So what you do is you just grab this equation here. I like to put it in a square bracket because there's going to be a minus 9 on the outside there. And you see this x here? I'm going to replace it with x plus 2. And then that minus 9 will just chill on the outside. And now I'm going to go on a bit of a mission to simplify this thing. Okay, so plus 2 minus 2, they actually cancel each other out. So I'm just left with a minus x squared over there. There's not even a use for these square brackets, so I'm going to get rid of them. I only had them there to illustrate what was being changed. And then on the outside, plus 9 minus 9, they cancel each other out. So here's h of x. And our 2 marks come from the necessary substitution of replacing this x with x plus 2, as well as gluing on that minus 9 at the end, as the question instructed us to. And the second mark just comes from the answer. 5.1.5 asks us, how can we restrict the domain of h of x? This is h of x. None of these graphs are h of f. This is f and g. So we're looking over here. Restricted so that the inverse of h will be a function. So what this graph looks like is it's a sad face that goes through the origin. So h of x will look something like this. And what I essentially want to do is I want to chop off half of it. So I want to get rid of this half, or I can get rid of this half. The norm is to get rid of the negative half. Everyone just does that. So to do that, what I need to do is this. So to chop off that half, I need to say x must only be bigger than or equal to 0. It can't be anything smaller than 0. Bear in mind, you can have a different notation. The other notation is also accepted. So the other notation will look like x starts at 0 and then goes on for infinity. So you can use either or. This is the one that's most widely used, but you can use either or. And why we do that is so that the inverse will be a function. So the inverse will look like this. If I did not restrict the domain, then the inverse would have looked like this. And that is not a function because it fails the vertical line test. Okay, I went down the rabbit hole a little bit there. Okay, the 1 mark purely comes from your answer over here. Okay, now I need to show algebraically that this is equal to that weird thing. Okay, if I'm asked to show, I'm only allowed to work with one side of the equation. So I'm going to maybe choose this side of the equation to work with. So let's grab that and make the necessary substitution. So what I've done is g of x, I've replaced the x with x plus half. So this x here, I replace it with x plus a half. And now we've got to kind of manipulate this thing to make it look like this thing. So I'm going to use an exponent law to split this up. And it's law 1 of exponents. So law 1 of exponents states if you have the same base and you're multiplying, you add the exponents. But I'm going to do this in reverse. I've got this side and I'm going to split it up into this side. So how you can notice how I've split that up. 3 to the power of x times 3 to the power of half. Now 3 to the power of a half, we can use an exponent law or we can just use our calculator to change that. So I'm going to use exponent laws to change this. The specific exponent law means we've got to convert this to a surd or a root. And this is how that law works. If I've got something raised to a fraction as an exponent, then this one goes under the root, this one goes outside the root, or if you're going this way, this one goes at the top of the fraction. Sorry, made a slight mistake there. This one goes to the bottom of the fraction, and this one will go to the top of the fraction. So over here, I can convert this into a surd by doing this. And 3 to the power of 1 is just 3. And I don't need this 2 here. If I have a square root, it's implied that there's a 2 there. So I can get rid of this 2. And now I've essentially almost proved what they've asked me to do. The root 3, I've got the root 3 over there. And then this is g of x. So I can just change this to g of x. And then my job is done. So let's have a look where the marks are coming from. So the 2 marks come from the correct substitution as well as the correct use of exponent laws. Alrighty, welcome to your challenge round 5.2. It gives us 2 functions. We've got a parabola here because I see x squared, and we've got a linear function here as represented on the graph they gave us. And then they give us this weird thing: f of x times g of x is less than 0 for all values of x when x is in between -6 and -3, or when x is greater than 2. And from that we need to determine the value of a in terms of m, showing all workings. Okay, so this is quite a complicated way of giving us points. So let's break it down and analyze it. So if we grab the statement here and we analyze it, it's basically telling you if I multiply the y values of the graphs, I'm getting a negative number. And for that to happen, one has to be positive and the other one has to be negative, because a positive times a negative gives you a negative. So to analyze that even further, you start scanning all the way on the left of the graph. So on the left of the graph here, I've got a negative y value, and the parabola will be like down there, and he's also got a negative y value. So it's not happening down there because I've got a negative y value times a negative y value. But as soon as I cross this point, it's going to start working, because then the green graph has a positive y value. But if I go down to the blue graph, he's got a negative y value. So it starts working over there, and they told us it starts working at -6. So I can conclusively say this point is -6. Okay, now I'm going to keep scanning after that. I've got a positive y value here and a negative y value here, so it's still working. Things are going to change when I cross this point, because as soon as I cross this point, the blue graph has a positive y value and the green graph also has a positive y value. So it stops working over there, and they told us it stops working at -3. So this point over here is -3. And now I'm going to keep scanning my graphs from left to right. This one's still got a positive y value. The green one's still got a positive y value, so nothing changes. Positive y value, so that's not working. Things are going to change when I cross this intercept. Now I've got a negative y value for my blue graph and a positive y value for my green graph. So it starts working over there again, and they told us it starts working over there again. So at this point over here is 2 and 0. So all of this mumbo jumbo was a really difficult way of giving you these 3 points. Now we're going to use these 3 points to our advantage. With these 2 points, we can get somewhat of the equation of the parabola. Okay, and to find the equation of a parabola, we use this formula. So we've got an a on the outside of the brackets, and it's x minus x1, x minus x2, And then x1 and x2 are just placeholders for the x-intercepts. So we have the x-intercepts of the parabola, they're here. So I'm going to chuck them into this formula and see what happens. So I just want to illustrate how you put them into this formula. So if I put minus 3 in x1's place, it's going to be minus 3, which will turn it into x plus 3 in our first bracket. And if I put 2 into this one's place, it's just going to be x minus 2. And now I'm going to FOIL the brackets. After I've FOILed the brackets, I'm going to distribute this a inside the brackets. And then that's like as far as I can go. I can't really go anywhere from there because I don't have a different point to sub in and solve for a. So that's pretty much as far as I can go. Now I'm going to direct my attention towards the green graph, G. So let's grab the standard form for a linear function, y equals mx plus c. And now I'm kind of going to do what I did with the parabola. I'm going to sub in what I can here. On the green graph, I only have one point here. So I'm going to sub that in over here. The y value is 0, so that will go in y's place. And the x value is minus 6, so that will go in x's place. After making that replacement, I'm just going to simplify things a little bit. M times minus 6 is minus 6m. And then I'm going to take that minus 6m over to the other side and it becomes positive 6m. And now what I have is an expression for the y-intercept for both the parabola and the linear function. So c is the y-intercept for a linear function. And this number at the end here without an x is the y-intercept for parabola. And if we look at the graph, they both have the same y-intercept. C is the y-intercept of the blue graph, and C is also the y-intercept of the green graph. So if they're the same, it means these two things must be the same, so I can make them equal each other. And then the question wanted the value of a in terms of m. That's a fancy way of saying get a on its own. So to get this a on its own, I divide both sides by negative 6. And negative 6, or 6 divided by negative 6 will just give you this negative 1 in front. The 6's cancel. And a equals negative m will be our final answer. Yes, this is a level 4 question if I've ever seen one. Right, let's see where our 5 marks are going to come from. Your first mark comes from substitution into the parabola formula, so this formula over here. The second mark comes from simplifying that mess into this line. The third mark comes from subbing this point into the linear function in this line here. Fourth mark is equating the two y-intercepts or subbing one into the other. And the last mark, the fifth mark, comes from a equals negative m, the final answer. Alright, so question 6 gives us an exponential function, 2 to the power of x. Anything to the power of x will be an exponential function, the ramp that goes like this. And we've also got a log function. A log function is like a sideways ramp. So let's color code these things and get to know them a bit better. Okay, that looks a bit better. So now I need to write down the coordinates of a, the x-intercept of f. So if I'm instructed to write down, it means that there shouldn't be any working out involved. And a will be 1 and 0. Okay, now you might be wondering how I know that. So let me quickly explain. So if we're working with the log function, you can see a is on the orange graph, the log function. And if we're working with the log function, it revolves around the logic that anything to the power of 0 is 1. I'm going to quickly work it out for you and show how I know this off by heart. So if I grab the equation, remember f of x is a fancy placeholder for y. And I know definitely that the y value of a is 0. Because a is an x-intercept, and x-intercept you make y equals 0. So I'm going to change this y to 0. And now I want to switch from log format to exponential format. So my base is the small number at the bottom. This is my exponent, so it's a half to the power of 0 equals x. And then we've got a sneaky little exponent law there. Anything to the power of 0 is just 1. And that's how I get this x value of 1 over here for a. But technically you should know that off by heart and be comfortable enough just to write that. And your 1 mark here purely comes from the correct x value of 1. Okay, 6.2 asks me to determine the domain of f. F is the orange graph. So it has a sneaky asymptote that isn't indicated on the graph. So its sneaky asymptote is actually the y-axis, which doubles up as an x value of 0. So that's where the orange graph starts with its x values, and it goes on forever that way. So how we're going to say that is it starts at 0 and it ends at infinity. And we have to say x is an element of for domain. And when we say that, both of them must get circle brackets. The 0 gets a circle bracket because it's an asymptote. And infinities always get circle brackets. That's just a small rule you need to learn. Bear in mind, another notation was possible here. I could have just said x is greater than 0. It means the exact same thing as this. If x is greater than 0, it implies that it goes on to infinity. And then the 1 mark just comes purely from your answer here too. Moving on to 6.3, it asks us to determine the equation of the inverse. F to the minus 1 is representative of the inverse in the form of y equals something. So it's the inverse of f. So I'm going to grab the equation for f. And then to get the inverse, I need to perform two things. I need to swap x and y, and then get y on its own. So remember, f of x is a fancy placeholder for y. And then I swap the position of x and y like so. And now to get y on its own, I need to change from log format to exponential format. And I've got to rearrange it like so. I put my answer first, and then my base goes after the equal sign, and my exponent comes there. This one over here will be my exponent, and the small number at the bottom forms my base. And now I've successfully done what they asked for. Get the equation of the inverse in the form y equals something. So y equals a half to the power of x. That's the equation for my inverse, f negative 1. And your 2 marks come from swapping x and y in this line, and your final answer in this line. So after getting the equation of the inverse, they've asked us to sketch this thing now. And we need to indicate the usual stuff. So let's think of exponential functions, because this is something to the power of x. So with the exponential function, we analyze our a value first. Our a value is the number in front of the base, which is just 1 in this case. So a is positive, so I don't even need to worry about these two. And now I analyze the size of my base to determine which one it's going to look like. Our base is not bigger than 1. Half is in between 1 and 0, so our graph is going to have this shape over here. And we don't even have a q value here. If we don't have a q value, we assume it's 0. So our horizontal asymptote will be on the x-axis. So let's go ahead and do a Cartesian plane and draw a shape in like this. After we've drawn in our shape, we just need to indicate the intercepts of the axes. So we need to indicate this point over here. Bear in mind, it is the inverse of this orange graph here. So I can just swap x and y there to get this point over here. And then I can get any other point on the graph. I like to kind of put 1 into x's place so that I get this point. It's kind of the easiest go-to point to get. Now to get the y value, anything to the power of 1 is just itself, so it's going to be a half. Bear in mind, you can check that with your calculator as well. So you can just pop that in the calculator, press equals, and you can see it stays a half. And then your 3 marks from this question come from the correct shape of the graph, the y-intercept of the graph, as well as another point that's indicated on your graph somewhere. 6.5 asks me to get to determine the equation of the asymptote of G. So remember, G is our red graph and its asymptote is over here, and I'm going to use this point to get the y value for this asymptote. So I'm going to have to use the orange graph, and I'm going to put this half into x's place over there and solve for q. And this is only worth 1 mark, so it shouldn't be that difficult to calculate. But let's go ahead and put that half into x's place here and see what it spits out. Okay, that's going straight in the calculator. It is going to give me 1 if I put it in the calculator, because anything to the power of 1 doesn't change. So just to further amplify that, gives me 1. So yeah, so now I know this q has a value of 1. So the equation for the asymptote is y equals 1. And your 1 mark in this question solely comes from the answer for that dotted line, the asymptote of G, which is y equals 1. And then the last question from question 6.6. Describe in words the transformation of G to the inverse of f. So they're basically saying, how did I change this graph into this graph? So we can see it's been reflected over the y-axis because it points in the opposite direction now. So there's our first transformation. And then the second transformation is basically we've got to move this asymptote down on the x-axis. So this one already has its asymptote on the x-axis. So to move that down to the axis, we just need to move it 1 unit down. So we just say translate 1 unit down. And then last but not least, let's have a look where those 2 marks came from. Each description or each basically transformation will get you a mark. So reflected over the y-axis, first mark, translate 1 unit down, gets you the second mark. In question 7, we are starting off with financial maths, and we've got an investment that earns interest at a rate of 7.5% per annum. That's what PA stands for, and it's being compounded quarterly. And with this, we need to calculate the effective annual interest rate for the investment, and this requires you to know this formula off by heart. This formula is not on your formula sheet. Okay, so here's our formula. Now the interest rate, the effective interest rate, is what we're looking for, so I'm going to leave this here. Now when I put my nominal rate in, this is the nominal rate because it's being compounded quarterly. A nominal rate is not yearly, an effective rate is a yearly rate. When I put it in, it has to be a decimal, so I divide that by 100. And when I divide it by 100, it gives me 0.075, so I put that in place of our nominal, the nominal interest rate. And now my n can be different things. It depends how it's being compounded. This is being compounded quarterly, which will make my n 4 because there's 4 quarters inside of 1 year. And now that I've subbed that all in, it's going straight on the calculator. So if I pop that in and press equals, I get this. I'm going to keep that to 4 decimal places. And I'm not quite done. I'm going to need to multiply this by 100 to get an effective interest rate. And then don't take any chances. Just use your calculator to double check your arithmetic there. So we get 7.71% as our effective interest rate. And then just bear in mind your effective interest rate will always be higher than your nominal rate. So it's a good little way to check if you're on the right track and you didn't make a working out error. And your 3 marks here will come from your substitution, simplification, as well as the final answer. Moving on to 7.2, we've got a bit of rhino poaching happening here. And there was 60,000 black rhinos in 1970, And then in 2011, only 4,200 remain. Geez, that's a bit scary. Now we need to determine the annual rate of population decrease as a percentage over these 42 years if the rate is compound decay. So compound decay, the formula is on your formula sheet. It's like compound interest, but with a minus instead of a plus. And how I like to see it is A is the ending amount, P is the starting amount, your interest rate, and remember it must be a decimal, and that's what we're solving for. So we're going to leave that behind, and N will qualify as the number of months, quarters, half years, or years, depending on how this thing is being compounded. Population decrease is always compounded in years, so we can get rid of these three. And now we can pop all our stuff in. Our ending amount, we ended with 4,200 rhinos, so that's going to go into A's place. P, the starting amount, we started with 60,000 rhinos, so that's going to go into P's place. The interest rate is what we've been asked to determine. The annual rate, determine the annual rate, so we leave the R there. Then the number of years, there's 42 years involved in this timeline. So I'm going to put 42 inside of N's place. And now I'm going to go on a mission to solve for R. So the first thing I want to do is get rid of the 60,000 by dividing both sides by 60,000. When I do that, these 60,000s will cancel, and then this is going straight on my calculator. Okay, when I pop this into the calculator, you can leave it as the fraction or the decimal. It doesn't really matter. I'll just put the decimal. Now I need to get rid of this power of 42. So I'm going to 42 root both sides, like so. And when I do that, these 42s will cancel because they divide with each other. Then this goes straight in the calculator once again. And then to type that in your calculator, you need to press Shift and then this button over here to get that empty square root where you type in 42. Press equals, and I'm going to keep that to 4 decimal places. And we are almost there. I'm going to take this 1 over and it becomes -1. And if I minus 1 from that side, I'm going to get minus 0,0614. And then just remember this negative is still glued in front of the R. Now I'm going to divide both sides by -1 to get rid of the negative. So essentially both sides just change to a positive here. And then I just need to multiply this by 100 to turn it into a percentage. So don't take chances, be sure to do that on your calculator. And there lies my final answer, 6,14%. And then last thing, let's quickly have a look where the 4 marks are coming from. Substitution in the correct formula gets us our first mark. The correct N value of 42 gets us our second mark. Our simplification steps gets us the third mark. And the last mark will come from our final answer. And the last question in 7.3 is quite a complicated one, but not too bad. Adam inherits 27 grand, which he invests in a savings account. Yes, what a dream. How lucky is Adam? The interest is calculated at 5.4% compounded monthly for the full period. 3 years after he invested the initial amount, he withdraws an unknown amount of money to make a down payment on a car. We need to calculate the value of X if he accumulated that much in savings in the account after 10 years. So with withdrawals and deposits like this, you have to do a timeline. Timeline is the only way to go. So let's set that up quickly. Alright, that structures the information very nicely. So we initially deposit, well, Adam initially deposits 27,000 Rand. That's going to sit for 3 years, gaining interest at 5.4% compounded monthly. He withdraws a certain amount, and then what's left over will sit for another 7 years because the total investment is worth 10 years. So 10 minus 3 will give me the 7. And right at the end, I've got this amount left in the savings account. So what I'm going to do is I'm going to do my compound interest to see how much money was here before he made the withdrawal. So let's grab the compound interest formula. Okay, compound interest, very similar to the formula we saw in the last question, except it's got a plus here because it's gaining interest. Okay, so I'm looking for the ending amount after 3 years. So this A is going to stay here. My starting amount P is 27,000, so I'm going to put that in P's place. Okay, now the interest rate must be a decimal, and I've got to divide it by 12 because it's being compounded monthly. So let's get that accomplished over here. And then because we're compounding monthly, we've got to put the number of months in n's place. So in 3 years, there are 36 months because there's 12 months per year. Once again, all these mental calculations, use your calculator to triple check them. Okay, and then this mess is going straight on the calculator. And when I pop that in the calculator, it gives me 31,000 Rand and some change. I'm going to round that off to 2 decimal places. And then just remember to use the Rand symbol in front of your answer. So now I've sorted out the first 3 years of my timeline. Now I'm going to direct my focus to these 7 years. I want to kind of work backwards through the timeline to see how much money was left over after the withdrawal. So I'm going to use the same formula again. Okay, now my ending amount is this 17,614 and 76 cents. So that's going to go into A's place. P, my starting amount, is actually what I want to find out. I want to find out how much money was sitting there after the withdrawal. So P is going to stay there. Okay, then the interest rate as a decimal is going to be exactly the same here because it's 5.4% compounded monthly. And then to get the number of months in 7 years, I'm just going to multiply that by 12 on my calculator. I think it's 84. It is indeed. So we're going to change this N to 84. And now I'm going to work on getting P on its own here. The easiest way to get P is just to divide by this whole thing, this bracket. And when I do that, they're going to cancel on this side of the equation. And then this side of the equation goes straight in my calculator. Okay, after I pop that in my calculator, I just press equals. And I get 12,080 Rand with 41 cents. And it is in a feasible region. It has to be smaller than that because it would have gained a lot of interest over those 7 years. Alright, and we are nearly at the finish line. Okay, so after 3 years, this sits and it becomes this amount of money after gaining a bit of interest. And if I take that money and take away the withdrawal Adam made to pay for his deposit on the car, then it's going to leave me with this 12,080 Rand with 41 cents. So to get this missing X value, I just have to say this amount minus this amount. The difference will be the deposit he withdrew to pay the down payment on his car. And then that goes straight in the calculator, press equals, and you get 19,656 Rand and 28 cents as the withdrawal that Adam made. Okay, last thing over here, let's see where these 5 marks are coming from. Okay, so substitution gets you a mark a pop for each one, the first 3 years and the last 7 years. Your answer for the last 7 years will get you a mark. The simplification to justify how you got X will get you a mark, and the final answer gets you the last mark over here.